Okay guys, so I can't be there today, so we're still going to review just through this video. So make sure that your eyes are up on the screen and that your mouths are closed and that you're paying attention. So one of the first things we talked about was the law of conservation of mass. Now, if you were studying like you were supposed to, you will remember that the law of conservation of mass, or matter, either one, says that matter, which is made up of atoms, cannot be created or destroyed. That means that they can only be rearranged. And so this law has many applications. Okay, if we take an example, let's take water. Well, excuse me, hydrogen gas. Remember that a G in parentheses means gas, plus oxygen gas produces water. Okay, one way that this law is applied is we know that the atoms have to be on the same side, the same number on both sides. So we know that our arrow splits our reaction, and to the left we have our reactants, and to the right we have our product. Okay, and I'm actually going to redraw this reaction in a picture format. So if I have two hydrogen atoms, they're going to be green for us today, plus my oxygen atoms, which are going to be red. Okay, they produce something that has one oxygen and two hydrogens on it. Now, you might be wondering, why do I only have one oxygen? On the left side, on the reactants, I have two of them, and on the right side, I only have one. Okay, and this means that the law of conservation of matter is not being followed. It's not balanced. And so what we can do is we can list out our elements. We have hydrogen and oxygen on this side, and hydrogen and oxygen on this side, and we count how many we have. Now remember, this number here, the subscript, shows me how many hydrogen atoms there are. So that means I have two hydrogen atoms, and this 2 tells me that I have two oxygens. Now on the product side, this 2 tells me that I have two hydrogen atoms, and whenever there is no subscript, it's like there's a 1 there, but chemists are lazy. So that 1 tells me that I only have one oxygen. So we see that we're not balanced, which we could already tell from our picture. So what we do is we pick the side that has the lowest number. So my hydrogens are equal on both sides, but my oxygen has 2 on the left and 1 on the right. So I'm going to choose the right side because it has the lowest amount. And I'll say to myself, what number, what coefficient can I put in front of my molecule that will multiply and change my answer to be what I want? And I want my answer to be a 2 to match this 2 on my reactant side. So I know that if I multiply 2 times my 1 oxygen, that changes my answer to 2. But hydrogen and oxygen are bonded, meaning what happens to one happens to the other. So I'm also going to end up multiplying my two hydrogens. And so that means 2 times my two hydrogens is now 4. Well, I have two oxygens on both sides, which is excellent, but now my hydrogens are messed up. So I pick the side with the lowest, which would be my reactants, because 2 is smaller than 4. And I say, okay, found my hydrogen. What number can I put in front of my hydrogen to multiply by it to make it into that 4? And I say 2 times 2 changes my answer to 4. And now both are equal and I'm balanced. Now how does this balance our pictures? Well, this 2 right here, my coefficient, tells me that I need 2 molecules of H2. So not only did I need this first one that I had already drawn, but I actually need a second one. And then this 2 in front of the water tells me that I actually need 2 of the water molecules. And now if I count those up, I can see I have 4 green circles on the left and 4 green circles on the right. I have 2 green circles on the left and 2 red circles on the right. So I'm balanced. So that was kind of just like the general overview of what we've been doing. Okay, so we need to move on to the indicators of a chemical reaction. Okay, now with our chemical reaction, we saw many demos the other day. So we talked about how, oh man, my eraser's going crazy here. But in our demos, we talked about how you have the, you can have an odor, right? When eggs go bad, you know that they're bad because they smell rotten. We can talk about an unexpected color change or temperature change. So color, temperature change. You can have light emitted. We saw that with the magnesium. You could have gas formed. And you know that a gas is formed when you see smoke, bubbles, fizzing, anything of that nature. And you can also have a precipitate form. Now remember, a precipitate is a solid. So this is, remember when we had a clear liquid plus another clear liquid, we added them together and we produced a yellow solid, right? We had an unexpected color change and we also had that precipitate form. That's how we knew a reaction had occurred. Now on this test, you're going to see a couple of questions that you might recognize from your last test and things that we're kind of reviewing and going back over. But remember that if you have the periodic table, okay, and you have your little staircase over on the side, pardon my terrible drawing, anything to the left of the staircase is a metal, and anything to the right is a nonmetal. Okay, now metals always form cations, okay, meaning that they're positively charged, and nonmetals always form anions that are negatively charged, because remember, cats have pos, cations are positive. Okay, now if you have a normal atom like magnesium, okay, when it loses an electron to become a cation, its atom gets smaller. Okay, so the cation, is smaller than the normal one. But if you have something like nitrogen, okay, you've got the normal atom, nitrogen is going to gain, and actually magnesium will lose 2 electrons, but nitrogen will gain 3 electrons. And when it gains 3 electrons, it becomes nitrogen with a -3 charge, and it's actually going to be bigger than the original one. Now, with that being said, don't forget about how you name things. If you have a metal, right, if you have magnesium plus 2 and you have SO4 minus 3, okay, positive 2 and -3 do not cancel out, so we cross and we drop, and we become Mg3. We drop the negative sign, SO4 with the 2 outside of it, and we use the parentheses to show that that's a polyatomic ion and that I have 2 of everything inside the parentheses. Now, with that being said, if they give you Mg3 SO4 2, okay, you need to remember, and actually this, you need to recognize that Mg is a metal, which makes it ionic. So this will be magnesium. And then we find SO4 on the back of our periodic table, and it'd be sulfate. Now, if you're naming something that's off the periodic table, for example, NaCl, okay, Na is going to be sodium, and Cl is chlorine when you look at the drawing, but we change the ending from INE to IDE to be the new ending. So anytime you see IDE, that automatically means look at the periodic table. Okay, that's what you need to do there. And don't forget, we reviewed this in our warm-up last class, but as you go across the periodic table, the atomic radius gets smaller. And as you move down the periodic table, it gets bigger. Now, the key thing about that is that all the other trends are the opposite. So that would include electronegativity, ionization energy, reactivity, all sorts of things. Okay, so that's just kind of what's going to happen there. So using this review, you should be fine for your test. Make sure you turned in your study guide for some bonus points if you completed it. If you didn't complete your study guide, well, you should have done it. So good luck. See you next class.